Let's take a look at this problem. Sam invests a total of $5,000, part of 7%, and the remainder of 13%. How much does he invest at each rate if his annual interest is $560? Couple of different ways you could work this problem. You could work it with solving systems of equations, and that's the way I'll solve it. Okay, so Sam invests a total of $5,000, part of 7%, remainder is 13%. So we're going to have X is equal to the amount at 7%, and Y is equal to the amount at 13%. To begin with, they say invest a total of $5,000. So they're telling us right away that X plus Y is equal to 5,000. And then they also tell us the total interest. And interest is equal to, normally, times your principal times rate times time. But here we're assuming time is 1 year, annual, how much does invest. So, and it doesn't specifically say it, how much does he invest at each rate if his annual interest is, I guess it does, annual. I should read the problem closer. So we're going to take our percent, which is 7%, times our amount, which is X, plus our percent, which is 13%, 0.13, times our amount, which is Y, and that's going to give us our total interest, which is 560. Now, the interest problems are always the same setup. If they give you the total amount invested, then you always do your X plus Y is equal to 5 equals the total. If they give you the total interest for the year, then it's always the percent times your amount plus percent times your amount is equal to your total interest for the year. Now, other variations may cause you to work this differently, but that's for this setup, for this way this problem's worded, that's how I use setup. Now, I don't like decimals personally, so I'm going to multiply this second equation by 100, or move my decimal point 2 places to the right. Okay, so my first equation is still X plus Y is equal to 5,000, and that becomes 7X plus 13Y is equal to 56,000. I move it 2 decimal places and it becomes that. Now I'm going to solve this by the addition method, and I'm going to eliminate the y's. So I'm going to multiply the first equation by negative 13. Negative 13 times x is negative 13x. Negative 13 times y is negative 13y equals 5,000. Let's try it again. Should be able to do basic math better than this in my head. 65,000. Let me double check that. Yeah, that looks right. Then we got 7x plus 13y is equal to 56,000. Now we're going to add these together. We're going to solve it using the addition method. Negative 13x plus 7x is negative 6x. Negative 13y plus 13y drops away. Negative 65,000 plus 56,000 is negative 9,000, I believe. Then I'll divide both sides by negative 6. And let me use a calculator. 9,000 divided by 6 gives us 1,500. Okay, well, to begin with, X is our amount at 7%, so that means we got $1,500 in the 7% account. And if we got a total of 5,000, 5,000 minus 1,500 gives us 3,500. So we'll have 3,500 in the 13%. Now, instead of using the addition method, I could use matrices. Now, if you took a look at how to do matrices, and fantastic, this will refresh your memory. If you've never seen matrices on the calculator, then don't even bother watching this part. We're going to drop our x's, our y's, and our equals, keep the numbers in their signs. So we've got 1, 1, 5,000, 0.07, 0.13, and 560. Now, a calculator doesn't care if it's decimals or not, so you don't need to worry about that part. It handles it just fine. So I'm going to go do a second x negative 1. Right arrow twice over to edit, or left arrow once. Press enter on A. It's a 2 by 3, rows by columns. So you do 2 enter, 3 enter. And we got 1, 1, 5,000, 0.07, 0.13, 560. Now I'll exit out, so I'll do second mode. And then we'll do second x negative 1, that's our inverse button. Right arrow to math, up arrow to RREF. Press enter. Go back in the matrix menu, do enter on A, enter again. And we get 1001, 1500. And 3500. 2 equations, 2 variables. Our first 2 by 2 here should be a diagonal 1, 0, 0 else. That means it worked. And our far right column is our answer. So this will be x and this will be y. So we get the same results using the calculator then.